Hello friends, FEU, whoever you are. Welcome to Snek's Buildfile tutorial, brought to you by Snek, in case you couldn't tell. Hi guys, I'm Snaky1, better known as Snek by now, probably around the community. I've been in FEU for about 3 years. I'm working on Legends of Avenir, in case you're curious. I do some wizardry or assembly stuff, custom assembly hacks. I do eventing, maps, text editing, basically anything. And I'm here because of a need for a coherent build file tutorial, honestly. Ultimate Tutorial 2 is oftentimes outdated and just pretty incomplete. And so I thought that maybe a video tutorial would be something that would be good to try out. Seems that the community is in support of it, so let's try it out. So I'm just going to jump right into it. I've created a very small, just very basic rudimentary build file right here. This is really as bare bones as you can possibly get. I have event assembler, UPS, which is for auto-generating a UPS patch, a clean FE8 ROM, our CMD script that we run to build our new ROM, and our master event file, which is just a text file. The file extension doesn't mean anything as long as you know how to open it. My text editor of choice is Notepad++. I hear Sublime also works very well. Anything that has really, use whatever you want. That's kind of the beauty of it. If you want to look inside what makehack.cmd is, it's kind of terrifying. Not gonna lie. It's batch, but what we need to do is we need to tell event assembler, which is just some software that is what we use to write to the ROM. We need to tell it exactly what we need to do. So I have this set up that you can change these input-output values. This is our clean ROM. This is whatever it's going to be outputted. Output UPS, and the event file that we input. I wouldn't change anything below here unless you're asking for trouble. Batch is notorious for being just sadistic. But anyway, I can run this right now without error. It doesn't do anything, but it does generate our new GBA file, which is what we're going to call just new.gba. It also generates this new.ups, which is just a UPS patch that we can apply for debugging if we want to send something, if we want to send a release or whatever. Right now, because we don't have any changes set up in our event script, it's just the same as clean.gba. It's just FE8. FE8 is great, but we're here for having not clean FE8 or FE7 or whatever you want to hack, even though FE8 is the preferred engine nowadays. So this event file is just going to contain any changes. These don't affect anything because these are just comments. In case you hadn't deduced by now, these double lines here, actually I'm going to put it below our agenda here. This is a single line comment. Blech, can't spell. In case you didn't know by now, Snek can't spell. This doesn't affect anything. This is a block comment. We can put as many lines in here as we want. And we just terminate it like this. We can terminate it like this. We can do this. It doesn't matter. So I'm going to delete these because I just did the title and agenda like that. But what we've done now is pretty cool. This is our first build file. We did something. But let's actually make a change now. Actually, before I do that, maybe I want to talk about why we would use build files. I have this agenda. Let's maybe follow it. So it's pretty clear that Feditor, Nightmare, GBA Graphics Editor, all of those have been pretty phased out and replaced by either Buildfile Gang, FE Builder Gang. FE Builder is GUI guided user interface software developed by 7743, which is pretty cool. It lets you do a lot of stuff, but it mostly follows the older older mantra. I don't know if that's the right word, but it kind of follows the older ideals of we have a working ROM and we're just going to build off of a single ROM, make backups so that we stay safe, which is normally works pretty well for smaller projects. But when you start getting into larger projects like fully fledged Fire Emblem hacks with, I don't know, 10 or more chapters or whatever, build files really start to show their strengths. We get pretty good debugging. We can use GitHub so that we don't have to automatically make backups of our source code. Because we have source code with our debugging, we can comment something out, and we can find what breaks. We can create a custom organization structure, which how we do that is we're going to get into later. We build files, there's a lot of conceptual things that you kind of pick up along the way when we work with build files and when you're learning how to use them. But when you insert something like, say, a map sprite or graphics with FE Builder, it normally just sticks it onto the end of whatever free space you're using, or if you've used that up, to the end of the ROM. You don't really have control over where that goes. With build files, well, it's not so much you don't have control over where it goes, it's more so you don't really care where it goes. You can kind of stick it wherever in free space, and as long as you know how to reference it, then you're golden. And when you rebuild, if you change some things around, it's likely going to go somewhere else in the ROM, but we don't really care where it goes. It's just more so we know where it is each time we build it. And we do that using labels, which we'll also get to. And with build files, you just more or less have more of a sense of control. You're not really limited to a user interface. A text editor and file explorer or command prompt, if you're fancy, can be pretty daunting at first, and we shuffle around a lot of tools. Like, we'll get into this later, but we have a tool that's used for inserting tables, a tool for text, a tool for graphics, stuff like that. Those can be pretty daunting. I'm not going to lie about that, but they're extremely flexible, which is really nice, and that's where it really starts to show its strength with larger projects. Space efficiency really isn't an issue because we have 16 megabytes to work with, and FE8 clean actually uses less than 16 megabytes because there's some pretty sizable free space blocks. So free space is cheap, though people with FE Builder have run into running out of space issues, which is a little scary, but with build files that essentially never happens unless you're trying to run out of space, which I hope you're not. Don't. And then once you get more advanced, then it's very wizardry friendly, which is basically if you want to write custom assembly. People claim that you can write assembly and use FE Builder, but if you want my 2 cents, you got to use build files. You can do it with FE Builder. It has been done before, but build files follow a source code pattern, which is how software is developed. And FE Builder is oftentimes just considered kind of hacky. It's really nice and easy to use for beginners, but once you get into the advanced stuff like assembly, then build files really just start to flex. So enough about talking about why build files. I think we've had enough of that. Why don't we talk about how build files? So we've already run our first build, kind of skipped ahead a bit and looked at make hack over here. Excuse me, I had to cough. There's a distinction to make between these scripts. Both of these would be considered scripts because event assembler reads this script master. Eventually we're going to add changes down here that start to write to the ROM. Make hack is a batch script, which means excuse me. It's a batch script, which all you really need to know is we could say your operating system runs that, and it's basically the precursor to event assembler running something. You don't need to know anything about how makehack works or why it works or whatever. Batch is terrible. Avoid it if you can. But just concern yourself with event assembler. To make double hack make click. Double click make hack. That's how you make it. And it's also noteworthy, we get this that pops up. No errors, which is good, because I haven't written anything yet. We have times, which is a nice recent addition by Stan, I think. Very fast, because we're also not writing anything. It also tells us that we copied a file. This line in makehack copies our clean ROM, and then we can write to it with event assembler. And if we do have errors or messages or whatever, they'll appear right here. We'll get there eventually. So I talked a little earlier about a build file and event assembler. All it does, in essence, is just a series of changes to write to a ROM, which it's a pretty simple concept at first, but we have a lot of power in building off of that. We have higher order operations that we can set up our definitions, and we can make it really smart with how exactly we want it to work. How we want it to work to make our final product that doesn't crash and plays pretty well. We can also explore what event assembler is. Event assembler is software, and we use it. It just writes to the ROM. It reads our script, writes to the ROM, it parses through stuff. We'll get more into how it works, but if you want to look at command lists that come straight from event assembler and not from me, event assembler language, at the top is things that are specific towards event assembler. If we go farther down, we get event codes. It's really called event assembler because it was initially designed for events. Most of these are just outdated nonsense. Eventing has come a really long way since these kinds of raws, especially at the bottom, were used. I mean, like, most of these are still, like, used, like enun, clee, clen, clee, remu. They're still used, but event assembler was originally devised for just writing events that didn't require a hex editor. And then advancements by Crazy Colors, Circles, I don't know the exact history. Stan's done a lot. Nintendo originally made event assembler, and it's now just a kind of all-in-one tool for writing anything you could possibly need to the ROM. We'll talk about macros later, but these are useful event macros. Not really helpful now, but because we're talking about what's in here, then I may as well cover it. We have event templates. This probably doesn't mean anything now, but when it does, we'll get there. I personally don't like this template. I actually have a custom template that I use that I might just end up using for when we get to events, but that's also something useful in here. Readmes if you're interested. Then we have EA standard library, which is mostly also events. We have what's not these. Sorry, not events. RAWs. No. I clicked the one that I wasn't supposed to click. But some of these are useful outside events, like writing a pointer. Stuff like that. I probably shouldn't go too in-depth with these. EA Standard Library has a lot of pretty helpful macros. So like most macros and definitions, which I hope should make a lot more sense later. Anyway, if this is a lot, it's really not that much. There's useful stuff in here that you can poke around with in your own time. Excuse me. Alright, so let's just jump into how we actually use Event Assembler. we have this script. Event assembler is reading it. It's expecting us to want to write data to the ROM. We've kind of deprived it of that, so let's fix that. The most basic and easy way that we can write data to the ROM is we can just... that writes a byte. This writes a short. This writes a word. A byte is 0 to 0xff, 0 to 0x. I'm hoping that 3, 4, 2, 3, 4, 5, 6, 7, 8. I'm hoping by now that you're more or less familiar with what a byte shorter word is. Yeah, so we can write these straight to the ROM, just like this. It gives us our first warning, writing before initializing offset. Well, we'll get to that later. If we open this in a hex editor, we've successfully written 0. I don't think 0 is there in clean. This is HXD, by the way. It's just free to download. We've made our first change. What does it do? It crashes. We can write a short. There are actually zeros there at the start of the ROM. We can write something other than 0. We can write, like, I don't know, let's be Mimi. So why not? I'm just in that kind of mood. Anytime we make a change to this script, we have to run makehack. That tells event assembler, hey, do your thing. We've made something new. We want to see some changes. It still crashes. I closed HXD. Yeah, so this is the hexadecimal representation of 6969. We could write it as a word, make more changes. If I was smart, I would have written it as OX6969. Then we could really see it, because HXD reads this in hex. Yeah, there we go. HXD does update in real time. So we're writing data to the ROM, but by default we're writing to offset 0, which is what this warning means. If we want to write somewhere useful that doesn't break the ROM, which is normally what we try to do, we use what's called the org command. Three, 4, 5, 6. 5, 6. Alright. This just goes straight to the end of the ROM. I could look up specific free space blocks. I'll probably add those in when I upload this along with the video, but just off the top of my head, I know that this is free space. So instead of writing to offset 0, we are going to write to the very end, right here. It's exactly 16 megabytes down. Is this really useful to us right now? No, because we're writing to free space without referencing it. But for demonstration, we're writing to the ROM. We can org elsewhere if we like. 1, 2, 3, 4, 5. I'd take this more seriously, but I'd just get nervous. And we've written to the ROM. Should I cover little endian? This normally isn't a huge issue when we write to, when we write with build files, because we normally just let event assembler handle this for us. But if you do look at in a hex editor, something that's noteworthy is the 4 and the 20, at least 20 hex, are flipped. This is something called little endian that this that FE8 uses. Actually, all GBA FEs. It basically just means that if you're writing a short or something, then if you're filling in the bytes, you fill them in reverse order. I think the technical definition is something like... Wait, no, that's for bits. Maybe it's something like the most important byte comes first? It's useful for when you're loading and storing an assembly. Don't worry about that. But we can write data somewhere. We can write data somewhere else again. Normally in build files, at the start of our build file, we declare something along the lines of... I'm going to do a block comment. If Notepad++ was going to stop having a stroke. Whatever, with folding. Whatever. Normally you'll see something like org free space. This uses a definition. And then everything before this just writes to free space. Like you'll have install text. Then we'll do the thing that installs text. Install CSV tables, which is going to be your chapter data table, your character table, your class table. Then we'll keep going. We'll have something like install maps. Normally we'll have something like install ASM hacks. We'll install events somewhere in here. Install graphics. I'm doing these out of order. I think events normally go last, text goes first. Let's see, text, CSV, graphics, ASM, maps, events. What am I missing? Music goes in here somewhere. Doesn't really matter where. For the most part, it can go here. This will be your general format for a build file. At least for a master installer. And we can do this because... I'm going to uncomment this. We can write multiple things after one another. If that sentence doesn't make sense, I hope it should make sense in a second. If if we have a bunch of writing commands that are here sequentially, I'm just putting in random crap. Okay. Oh, oof. Let's comment this. That's what an error looks like, folks. Alright. If we're writing sequentially, yeah. We have our nice numbers. Then it updates where it's writing to after that by 4, because we're writing a word. Then it's gonna write our tens. Then it's gonna write our slew of random ass numbers that I put down. Because I'm choosing to org do a new offset. And then it's writing our 420 here. So I've kind of mixed in some basic build file stuff along with sequential writing, which is just one of the basic components of build files. We can also do like this. Excuse me. These don't have to be these don't have to be single arguments. These can be as many arguments as you like. These that just write words, shorts, bytes. We can write a pointer. I'm going to get rid of this. Is there a ROM offset I know off the top of my head? Well, let's just pretend that this is a ROM offset. Normally we would do this with a definition, but we don't know how to do that yet. The pointer will add, where'd it go? It's down here. The pointer will add 8, which, God, I'm so sorry. I cough a lot at night. But it'll add this 8 to the address in this byte right here. That just basically means it's referring to somewhere in the ROM and not somewhere in RAM. This is anything that's going to be a constant, like the character table, the class table, animation data, music stuff, whatever. Anything that we can edit, if it has an address, it's going to be a ROM pointer. When we use the pointer command in Event Assembler here, this ensures that we're writing it as a ROM pointer address. Otherwise, it might be read as a not ROM pointer address, which would be bad and maybe cause a crash when we actually try to run stuff. But since we have this format where we're writing to free space, writing a bunch of data, be it large or small or whatever, what if we want to just pause? Pause writing to free space, write somewhere else that might be useful, and then jump back and continue writing to free space. We can do this with push and pop. Push saves where we're currently writing. Writing to. Pop gets it back. Push and pop, at least in utility, is going to be paired with an offset, a new offset that we're going to write to. Just so that we can see it show up, why don't I say it's, I don't know, somewhere in here. FF FE0 2 3 4 5. Is that too many? So my prediction for this script, it's going to start writing. It's going to write these 4 words. It's going to stop. Hang on. We need to write to a new offset. Jump to this offset. Write this byte 11 right here. Pop to get back to the new offset. Write this nonsense pointer at 100010. Yeah, because we wrote 4 words. Let's hope for no errors. Cross our fingers. Please continue being awesome. There we have it. We started here, wrote our 4 words. It jumped here, made a small change. Then we jump back. In practice, this is mostly for organization. We could live without push and pop, but it would be pretty terrible because normally in build files, we want to try to be as organized and readable as possible. So if we're installing a bunch of ASM stuff, this could include some installer that changes an EXP routine. It might need to write to free space. So in its installer, it would assume that the current offset we're writing to is free space, which is a safe assumption in a build file. But it might also need to change a single byte in the EXP routine for whatever reason. We can stop writing to free space with push, org to the new offset, write whatever change we need. With ASM, it's normally a short, or a few shorts. Pop to get the offset back, and we're safely writing to free space again. So that kind of thing is pretty common in build files. It's really more than just a quality of life thing. It's pretty essential for any good organization. Another thing that's good for data writing is alignment. So right here we could write some stupid byte. And then we want to start writing for-aligned. This align command makes sure it adds basically zeros. I think it's always zeros. It adds zeros until the offset to which we're writing is divisible by 4. As a general rule of thumb, almost everything that you're going to want to write, it needs to be for-aligned. Be it ASM, graphics, events, maps, like tables, like it just be like that. Whenever you do debugging, ask yourself, is it align 4? If not, try to align 4 first before coming for help. I'll probably clean out some of this nonsense stuff in a second, so it's getting a little hard to read, but we write our 4 words. Push pop doesn't affect anything to how we're writing to free space. But I wrote a byte, 34, to stay for-aligned with our pointer. Basically, whenever you write a pointer, like the only exception I can think of is battle animations, I think, has an internal system for that. We need to write it for-aligned. So we align 4. Our offset is divisible by 4. So we're all good. Always align 4, kids. Always. Don't align 3. Align is made to be for whatever you want it to be. You can align however you want. We used to think that character events needed to be aligned 32'd. I think I recently debunked that. So just align 34, not align 34. Align 4, kids. So these numbers are all fine and good. I'm going to comment this stuff out. It's starting to get kind of messy. It's all fine and good to write numbers, but what if instead of memorizing hex numbers for item IDs, class IDs, because if we're writing events or we're working in tables or whatever, we're going to want to reference what's a steel sword, what's a steel blade, like what's a vulnerary, what's Erica's class ID, character ID, what's the class ID of a Gorgon egg. I don't know why you'd ever want to know that, but like what's the class ID of a female general? I have no idea. I know, like, generally where they are in their hex IDs, but I've never needed to memorize them because of definitions. Back in the old days of switching between FE Editor and Nightmare and GBA GE, it was all about, like, if you wanted to be organized, you just had to be absolutely insane about writing down offsets and definitions and keeping everything under your thumb. Just micromanaging everything you could. And being that insane was the only way to stay sane with keeping things together. Event Assembler just handles that for us with a very simple command. My thing is now 4. It equals 4. Well, equals isn't quite right. What Event Assembler does with definitions is it replaces the string with whatever string this is. I can define my other thing as something else. Actually, let's actually put some notable things to these. Let's see. I think Iron Sword is 1. I think, isn't Erica Lord also 1? I could be wrong with these. Let's say thing, another thing. I'm probably wrong with those IDs, which just goes to show I just use definitions like crazy. So if we want to write these as bytes. Write byte, iron sword, Erica Lord, and thing. 0 for good measure. So I've cleared out all this old nonsense, so I'm just writing these here. Once I define iron sword as 1, Erica Lord as 1, whatever, thing, event assembler just knows what we're trying to do. Your definitions need to come before when you're trying to actually reference them. Oh, just another side note. I don't know if you've noticed, but I've been saving meticulously after I make any change. It's a habit you get into. It's a good habit to have. If I try doing something without saving, event assembler is going to get confused. And the script that event assembler is reading is not the script that's before your eyes. If I save, however, they're in sync. So just save meticulously. Anyway, if I put this before our definitions when I try to reference them, we get an error. Unidentified identifier. Bleh. Undefined identifier. Just means it doesn't know what that definition is, what you're trying to use. We'll get to labels later, but labels do not need to be defined before you try to use them, which is pretty nice. But that's just to clear that up. That's another thing. If you want to make a definition, it doesn't have to actually be anything. You can just make it that. But if you try to actually use it, this should error because it doesn't... Oh? No, it just doesn't write. Okay. You're not going to reference that, but you can use it, like for guards or whatever. We'll get into that later, but it is a thing that you can do. We can also make a definition with parameters. This is more commonly referred to as a macro. So we can say they're oftentimes used for math or kind of like if you want to consolidate some group of events or writing data or whatever, or even you can org with a macro. You can do anything with a macro. It's really good for streamlining things. My macro. And I'm going to say 3. No, that's not what I do when I define. Let's just call this an argument. There are no types in event assembler. It's just everything is strings. And then you write numbers. It's pretty nice. No types. And then let's just say my macro is byte arg. Arg. So instead of writing out arg every time, or like byte 3333, I could just do my macro 3. My macro 4. Three, 4, 4, 4, 4. Alternatively, I could have done this. And it still works the same, if just a little less elegantly. But maybe a little more flexibly, because I can do this if I want to. I don't know why I would, but I can. Just goes to show that macros are really flexible, writing 3s as words instead of bytes. This isn't really practical, this example that I'm using at all, but macros they're just really flexible. You can think of it as it equals this string whenever I have this value in here. Using this is the exact same thing as word 3333. It's exactly the same to event assembler. Let's maybe say what definitions are. Write these out for consistency's sake. Definitions are really cool, really flexible. We use them a lot. They're the bread and butter of any build file. Basically, definitions, labels, what else could you possibly want? There's a lot more. We can undefine a definition. So if I were to undefine Erica Lord, it no longer knows what Erica Lord is when we try to write it here. If I get rid of this, it should assemble just fine. Seems labels are next on the chopping block. This one can be a little tricky, it's a little more abstract than definitions because labels kind of flow and change with offsets that you're writing to as you change your build file. But they're pretty easy to declare. It's just my label. They essentially just keep track of offsets for you. Track of offsets as they change in... Oh, that's a little deceptive. God, I'm really sorry I'm coughing so much. But these offsets aren't changing within an individual ROM. I'm saying they change as you make changes to your build file and you rebuild your ROM. As you rebuild your ROM. So I can refer to my label. I can say, after all this, align 4, because we're writing a pointer. And we have now successfully made a reference to somewhere in the ROM. It's not a very interesting reference, because it's just pointing to right here after our bytes, but you'll see it is a ROM address. It's a 9 because we started writing after this 16 megabyte limit. Anything after there is a 9. Anything before there, is going to be an 8. And this is going to dynamically change if I were to add something else here. That address will be 90008 instead of 4. And here we are. Here's our new pointer. We point to right here in free space. Right where we start our 3333 nonsense with our macros. So normally labels, common labels that you may see are class table, like character table, maybe like someone's portrait graphical data, like, I don't know, Lucas portrait. spirit of... yeah. We don't really use them for text. We kind of use them for music, but we'll go there later. Yeah, we can really just keep track of any offset in the ROM. It's good for assembly. You'll see a lot of the time, like point, class, table. And so, if we are repointing the class table, which means we're making a new class table and inserting it in free space, we have to keep track of where the class table is in free space. Do we really care exactly where the class table is? No, because Event Assembler keeps track of it for us with labels, and then we can refer to those labels with pointers. I can also do this to show that we can make a pointer refer to a label before it's actually made, which is pretty nice. Because we added that pointer, it shifted up our label. An Event Assembler dynamically keeps track of that. Comment. Oh, I need to do scopes as well. This is pretty simple. Any label that's made within scopes is only going to be visible within those scopes. These curly braces are what we call the scopes. And it's going to give us errors that it doesn't know what my label is because it's hidden within these scopes. But if I have this first pointer within these scopes, it's going to remove this first error. Oh. Now the only one that's erroring, line 67 here, is this one, because it's outside of the scopes. We can be inclusive, make him happy, peer pressure him to make bad choices, and we get no errors. This is useful if, like, for animations, when you're installing them, that's going to have common label names that you don't care about outside the animation. You don't want conflicting labels, and if you don't care about them outside the animation installer anyway, then you may as well hide them from the rest of the build file. They're also really good for events, maps as well. So that's scopes. We hit undefine. We can start including files. I'm going to... By the way, if you're wondering when you start a build file, do I have to define every single vanilla item and every single vanilla class and character? And no, you don't. We'll get into that later. There's a library for you to use. So, when I'm talking about these installers, and I have something like install text, install CSV tables, this is going to use some kind of external file. Include is pretty simple. We really can't be expected to handle every single edit to the ROM in this one file. It'd be pretty big. We love our file, but we need to spread the love out to other files. When we include another file, it's just going to include those edits as if we had those edits right at that line. File.event. We can do whatever we want in here. Let's even add a push pop for good measure. Psst, why'd I even bother copy pasting? 1, 2, 3, 4, 5, 6. This is just all useless data, but no build file ever actually looks like this. I'm just doing this random crap, for example. Alright, we wrote some 40s, then we're including another file. We have our 6 zeros. It handles our push pop and writes our 543 in hex. I'm just grabbing random numbers out of my ass. Writes our nonsense here, which looks a lot like a pointer, which doesn't exist. And we jump back to our main file and write more random data. I don't think include is a very difficult concept. You can stack includes, so include more files. I'm not going to actually do that, because I feel like this is already going pretty long. Another kind of include that we have is called inc bin, include binary dot dmp, or dot bin is another. Actually, begin reading data. Let's change this to begin reading script, because we're going to make the distinction between reading an external script and insert raw binary from this file. .dmp. That's what I called it, right? Nope, just some binary file. All right. So if I don't want to mess with all these stacks of words and shorts and bytes and whatnot sitting around, or let's say I want to take the vanilla song table from FE8 without using a CSV and just stick it into free space somewhere and start writing to that. I can do that with a DMP. I could copy the entire song table into this DMP and then ink bin it to somewhere in free space. I'm not going to get the entire song table right now. I'm going to do this. Sure. hxd stopped auto-generating .back. So we've write our 40s, wrote our 60s, write this nonsense. So where are we? Here? We've written this, and now it's just including data straight from our binary file right here. Then it can continue going with more words or whatever. And this kind of long stream of writing data is just what a build file is. What other includes am I missing? There's going to be inc ext and inc text. We'll get into what exactly these are later, but for example, png to dmp, my image.png. Not going to use these now. Text lin, my.elf. Just so you know they exist, they call an external program, in this case png.to-dmp.exe, lin.exe, and they just pass that into whatever that program is. Inc.ext, include with extension. Just inserts it as a binary file, whatever the external program spits out. Inc.text actually runs the script of whatever it spits out. Not really important right now, but just so that you know they exist, they exist. I mentioned a little earlier that instead of just manually defining Iron Sword and all that kind of random nonsense that you would expect to find in a Buildfile project, that there was a library. Include event assembler standard library.event. You can basically consider this your magic keyword to get a lot of really useful vanilla definitions. There's a bunch of stuff in there. Items, characters, classes, music stuff is in there, AI stuff, macros, a lot of stuff for eventing mostly. I can say like from the darkness, that's going to be a short, because music be like Iron Sword is 1. I was correct. Erica Lord is 2. Damn it. From the Darkness, its song ID is 15 in hex. Cool. You'll see this at the top of a lot of like hack installers, just to make sure that you have the standard library installed. If you install it once and you install it a second time, it doesn't really do anything. It's not really so much installing as it is including it. There are guards to make sure you don't define everything twice. Another thing you'll see oftentimes is include extensions. Extensions. Hack installation.txt. Is that correct? Extensions. Hack installation.txt. And that's really an assembly thing, but that's another common one that you'll see. Event assembler, when it's including files, it also looks within itself for files to include. That's how that works. That's my own thing. Yeah, I spelled it right. We can do some miscellaneous codes. You can send yourself messages through the console. Hello there. You can send it as a warning message. You can also send it as an error. Message is just chill in blue. It's just chillin'. I like using messages to tell me where my blocks of writing data end and begin, and they also show up in real time as you write. So as you see messages write, you can see, oh, graphics just finished installing. That took a while, and it's nice to see. Warnings will not stop assembling, but it's normally like, hey, this isn't a fatal error, but you should probably check this out. Like, you'll get a warning if you redefine something. That's just something that event assembler does, but you can also force throw a warning for whatever reason. And then you can also force throw an error, and that will force it to not write any data. This kind of error is often used by hacks, and it checks, like, are you writing an FE8? If not, throw an error, because you're gonna do some bad stuff. There's also a variable that's used, it's current offset. Can I just do this? Oh, I should probably not give myself errors. And I should not cease. Alright. This variable current offset represents where we're currently writing to. So way back here, we orged ourselves to this free space right here. Wrote a little something to increment our org by 4. And current offset is now that plus 4, which makes sense, which is always a good thing. We can use current offset, like we can just word current offset. Just a little more useful than you might think it to be. Oh, I should probably make it a pointer if we want it to actually be an actual address. Show off the distinction between word and point. There we go. Now it's 9. Now it's a pointer address. Not really useful unless you know what to do with it. Protect just will throw an error if you try to write data somewhere. So we can do this. This is all like pretty niche stuff. I'm just going to fly through this. It's protecting this area right here. It's useful for like guarding the end of free space blocks if you don't want to start writing important data again. It's also useful for debugging, like if you want to find out what's writing to this in my massive ass build file, then you can protect that data and let it tell you where the error is coming from. This nice file path here just tells you, and the line number, hey, this is where this is happening. Assert will throw an error if the value is negative, I think. I'll cover math in a second, but it's pretty straightforward. Yeah. I use this for also protecting the end of free space blocks. I should be placing these in comments down here. How that works, I'll probably just include that in the master installer that I'll cook up eventually. Throw an error if this address is written to. Throw an error if this value is negative. As you may expect, current offset represents the offset to which we are currently writing. I didn't get these. Include with extension as binary. Include with extension as a text script. EA standard library. Alright. I'm going to put this one to rest. We can do small conditions with event assembler. Like we can say if defined, as well as if not defined. If def. There we go. If defined, let's say def, because I'm creative today. We're defined. And then every if statement must be paired with an end of if statement. End if. We're defined. If I comment this out, so event assembler ignores it, we are no longer defined. Event assembler handles else statements as well. We are not defined. I can just as easily go back. We're defined. Of if def. And this is what I was talking about when you don't actually have to define something as something. You can just declare something as defined. This is why you would do that. It's not something that you would ever reference in writing to the ROM, but it may be something that you would use in if-def statements. Then proceed until hit else or and if. If the previous if or if and def failed, proceed from here until we hit our end if. We can also chain these, so like if I want to do if def, another def and def, because I don't want to spell if and def. I could just stick that in there, and it works just fine. I think those are pretty straightforward. I haven't really talked about hexadecimal versus decimal yet, but event assembler handles both. They're really, with hexadecimal and decimal, they're just commonly used bases for numbers. Like OX10. Comment these out. OX10 is the same number as 16. They're just different representations of the same thing. Event assembler doesn't give any shits about what you use. Any shits about whether you use decimal or hex. You can even combine them in the same statement. Of course, HXD just reads hexadecimal, so these are both going to be OX10. Event assembler just writes it as whatever the number represents, and we let it do its own thing. By now, if you're watching this, you probably already understand hex versus decimal, but if not, that's okay. It's something you just get used to. And another thing that's pretty useful is event assembler is also capable of math. Actually, I'm going to refer to EA in here. Event assembler language. It has... Yes. I'm just going to copy paste this. Bruh. Plus, minus, multiply, divide. It's just like any other language, really. It follows order of operations. I can do even mix, hexadecimal, decimal. It's all cool. You can multiply them. It's probably, just in case it doesn't fit in a byte, whatever. It would. Would not. Order of operations is followed. This one should equal FF, I believe. Yeah. We can do math within macros. Let's do word. arg1. Let's say this takes... what should this macro do? I'm just going to multiply them together. Macro 4, 7. I mean, I think it's pretty straightforward. If you're not familiar with computer science, then, I mean, I hope you know this is plus, minus, multiply, divide. This is modulus, which just gets the remainder after you divide something. So like 8 mod 3 is 2, because the remainder of 8 divided by 3 is 2. And is logical bitwise and logical bitwise or logical bitwise exclusive or, I believe. Literal shift left, literal shift right. I won't get into bit logic in this. That's really more of a not specific to Buildfiles thing. But EA supports them. These are pretty useful. I think multiplication is good for going to a certain entry in a table. Division, I don't know if I've ever seen division used. I've never seen modulus used. Yeah. And that's honestly really about it. Seeing all this in this agenda is kind of quite a bit, but I just kind of went through it all. If you want a quick recap, org writes to this offset. Word writes 4 bytes, 32 bits. Short is 16 bits. I'm sorry, I just coughed right into the mic. Byte is just 8 bits. Push saves the offset to which we're writing. Pop to get it back. This is useful for often just changing things in the ROM, among other things in free space. If we wanted to find something so we don't have to memorize or reference hex values, then we can use our handy-dandy define command. We can define as many things as you want. I've defined thousands of things in Buildfiles before. It's pretty good. Macros are nothing but definitions with arguments. We can write a pointer, which is also 32 bits, which should refer to a ROM address. At least in EA terms, a pointer does. A label keeps track of where data is. At least that's its practical use. It really keeps track of an offset to which we're writing. There's nothing that stops you from, doing something like push org whatever the offset of the vanilla class table is. Class table. Pop. You can do that, but it's just as easy to just define class table. These actually don't have exactly the same behavior, but if you're doing everything correctly, then it shouldn't really matter. But no, labels are almost exclusively used for keeping track of data in free space. We can include external files if we don't want to keep everything in a singular file. We have our EA standard library for all our handy-dandy FE8 definitions. This is what I was talking about when we have all of this fun stuff. Most of our bread and butter FE8 definitions are in here. As you can see, we're following the defined format. But why are these register definitions and FE8 definitions? What? Whatever. Here I explored our sequential data writing with includes a little bit more. It's really no different. We just write data as we go. Event assembler knows where we're trying to write. We have external includes, which we don't really need to keep track of for now. We can message ourselves, warn ourselves, error ourselves, current offset, protect and assert. We don't use those too often. We can write data conditionally depending on what things we have defined. That doesn't change anything in the ROM, like within a singular build, but let's say you want to have multiple releases, like a debug release, a private release, a public release without debug features or something. If you just have a single, like, debug definition at the top of your ROM, and if you have your if-defs set up correctly, let's say we're in debug mode. Maybe you have like a win button or Konami code. I find those pretty useful. We're not in debug mode. Those are fun. Curb's debug menu is fun as well. That's a pretty useful application of that. EA doesn't care whether you use hexadecimal or decimal. Just know that hex is denoted by this OX before the number. Without it, it's just interpreted as decimal. And of course, there are mathematical operations as well. And that's as much as I'd like to cover in this one. This probably went over quite a while longer than I would have liked to, but I hope that I covered everything that's really important. In this series, I'm probably going to knock out text editing in the next episode as we start to get a little practical with actually making edits to the ROM. This would include custom text IDs as well as overriding vanilla text IDs. We're going to use Stan's Text Process Classic because it's awesome. And moving forward, I'm hoping that we can turn this baby itty bitty doesn't know what planet it's on build file onto a base build file that not base build file. Pikmin's already got that claimed. I guess if I have to brand this, I'd call it the Snek file, but I kind of hate that. But yeah, I'd like to turn this into a build file that moving forward through each of these I can build off of, and anyone who wants to begin using the build file method can start straight off with this without having to download all the CSV files and rip from the ROM using the Nightmare module to CSV.exe, all that nonsense, and getting started. Because honestly, the biggest hump in build files is just getting started. Once you have a working version of everything, it all falls into place. It's pretty nice. So, I'll just leave it at that. If you've stuck around for this long, thanks for putting up with me. Hope to see you in the next episode we do. I'll get that out eventually. Have a good night. Stay safe. Have fun.